The question we're having today says, at what respective values of x, y, z would the unit of density be dimensionally equivalent to m raised to power x, l raised to power y, t raised to power z? Now, before we solve this, these people want us to get the dimension for density. Now, we all know that density is given by mass all over volume. So we have to get the dimension for density. Then we relate what power does the M have, what power does the L have, what power does the T have. Is that clear? Now, the dimension for density, for us to get it, let me try to talk about the SI unit because I like using SI unit to define. Now, mass is the SI unit is kg, right? Volume could be length times width times height, but in this case, let's consider it is length times length times length. Is that clear? Now, volume is length times length times length. That is meter times meter times meter. That's cubic meter. Is that clear? So the SI unit for density is kg per cubic meter. So the dimension for density would actually be, dimension, if we consider mass, length, and what? Time. Where mass, wherever we see K, mass is measured in kilogram, right? Length in meter, right? Time in what? Seconds. So, but when we are talking about dimension, we do take these initials. So whenever we see kg, we know that it is mass. So we have to take m. Wherever we see meter, we know that it is length. We have to take L. Wherever we see second, we know that it is time. We have to take T. Is that clear? So this kg here is mass. So for the this is SI unit. Now when we are talking about the dimension, it is this one. So the dimension for this kg is m, capital letter M for mass. I hope it's clear. Then the slash m raised to power 3. This m is meter, right? Which is length. L raised to power 3. So if I want to write this, removing this, I will say that it is mass per cubic what? Length. Is that clear? Now it means that this is the dimension for what? For density. So with asking us what are the respective values of x, y, and z in the dimension for density. So if I ever relate this formula to m raised to power x, l raised to power y, and t raised to power z. Now, here is m, here is m, and what is on top of this m? It is what? 1. Is that clear? So I can say that x is equals 1 by relation. We are relating. I hope it's clear. Now, I have L here, I have L here. So minus 3 is in place of y, right? So it means that y, the value of y is minus 3. Now watch out, I'm having t raised to power z, but in the dimension for density, there is nothing like t raised to power z. So in this case, I can assume that the t is raised to power 0. Why? Because anything raised to power 0 is 1. And L raised to power minus 3 times 1 will still give us this. That's the more reason we are not seeing the 1. So I can say that t raised to power 0 is present, and we are not seeing it, it is 1. So in this case, I can relate and say that z, the value of z is 0. So in the SI unit of density, the value of z is 0, the value of x is 1, and that for y is actually what? Minus 3. I hope it's clear. So have a nice day. Like, comment, share, and follow Kosis Academy. Bye bye.